This is 1.2. So it is all mathematical models, sort of as, conceptual, because I'm just going to list out the types of models, and we will encounter these later on. So the book starts with a linear model, but I'm going to start with a polynomial. So a model and a function are one and the same. Some people use the word model, some people use the word function, but they are one and the same. Anytime you have a process, you try to write it as a function, you are trying to explain that process using a mathematical model, which is why a function and a model are one and the same. Me being a math stat person, I'll call it as a function. If someone worked in ecology or biology or fisheries, they will call it as a model, same thing. So the algebraic function that we always use has a general form, which is a sub n x raised n a sub n minus 1 x raised n minus 1 a sub n minus 2 times x raised n minus 2 a sub n minus 3 times x raised n minus 3 dot 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 all the way up to a1x plus a sub 0. Okay, so this is what we call a polynomial model. What does poly mean? Many. What does nom mean? Not food. Could be number, term, name, quality. Think it's name in Latin. We can always Google it. So here, many known terms, we have many terms, right? So have a lot of terms, hence we call it a polynomial. How many terms do we have? We have n plus 1, but you look at the highest degree, the highest degree will determine the degree of the polynomial. Here, n is the highest. So this is an nth degree polynomial. Good. Now, what about a sub n minus 1, a sub n minus 2, and so forth? So all of those they're all constants, and they are called the coefficients of the polynomial. So we have n plus 1 coefficients, and they're all constants. And this term right here is called the leading term. Good. So, why should I start with a polynomial model? Well, instead of starting at, say, n, I'm going to start at 2. Good. Mind you, as I go along, I can go all the way up to a1, and the last one must be a sub 0, a naught. Also, what is happening to the powers of x? They decrease, and they decrease exactly by 1. Okay. So if n is equal to 2, how would you write this? We started n equals 2, so
it'd be a2 x to the power of 2, then it would at the very least go between that, then it would go a1 x to the power, oh, x to the first power, which is again just a half x. And then at the very least you have a 0, which again a 0 is just going to be 1. That's why there's no x to 0 power, because it's just a is a 1. Or no, it's I'm sorry, not a is going to be 1, but x is going to be 1. That's what I mean.
I got it.
Yeah.
So should we stop right there?
Yep, that's true. I keep on mistaking things today. I don't know why.
Tried it. 4 times. So,
It's not too great when you're trying to answer a question.
so a2 x squared plus a1x plus a sub 0. We all know what that function is. Do we? Go ahead.
Quadratic.
It is a quadratic model. That's it. So ax squared plus bx plus c. Instead of calling it as a, b, c, I'm calling it as a2, a1, and a0. So we just derived a quadratic model.
So what we time.
If n is equal to 1, we will have f of x equal to, where should we start?
It's literally just
A sub 1, x raised 1 plus a sub 0, x raised 0. We'll end up having a1x plus a naught. X raised 0 is just 1. And you look at us, and what does that expression look like? It's a linear function, so it is a linear model. If n is equal to 0, we'll have f of x. Where should we start?
What was the question?
If n is equal to 0, where should we start?
Oh, just the equal 0.
At 0, right? So a sub 0, but I told you we can't go past that. So that's all we have. Now that is also a function. If you can't recognize it, let's say y is equal to a sub 0. Right? What function is that? Well, what would it look like on a graph? It's a flat line, right? That's the equation of a horizontal line. In other words, this is a constant function. No matter what x you pick, the value of y would remain the same. So it is a constant function. So all of those linear, quadratic, cubic, quartic, all of those come from that general form. So all these years when you learned about quadratic models, linear models, a horizontal line, you were actually learning about polynomial models of different degrees. What is the degree of a quadratic model? 2, highest bound. Linear model. 1. Here, 0. Does that make sense? So rational function, numerator polynomial divided by denominator polynomial. There is a possibility of a horizontal asymptote, vertical asymptote, oblique or slant asymptote. So f of x is equal to x raised to the power of a is called a power function, where a is a constant. Now I could multiply something here, I can add or subtract something there, I can divide that by something. Regardless, it's still a power function. Does that make sense? A power function is a polynomial with, all terms are 0 except the leading term. Does that make sense? So, examples?
Exponential model.
No. That's why I picked this one.
Wait, no, right, the.
I knew you guys would make this mistake. All of those are power functions. Typically, a between 0 and 1 is what we will go because these also fall under the category of a polynomial function, right? So this is a square root function, which is a power function. X raised -1/3 is a power function. I can keep on writing. So anything of that form is a power function. Now, why did I write this? Because of this. Exponential function. Oftentimes, students mix up the two. You can't. So, exponential function f of x is equal to a raised x, where a is a constant. And it is called the base. And that could be any number. See the difference between that and that? Here, the constant is in the power. Here, x is in the power. So if a is 2, we will get 2 raised x. Yes? If a is 3, we will get 3 raised x, and we can keep on going. If a is equal to e, we are not setting one letter equal to another letter. E is a special number, 2.71828, dot, 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 keep on going. Just like pi, right? E. So this would give us e raised x for the function. If I plug in a equals e raised x, we are simply saying instead of 2, I'm plugging in 2.7182, right? But you may ask me why e? To maintain accuracy. This base is called the natural base.
Could you cancel that out with natural log?
Patience. We will get there. That would result in, not result in, the logarithmic function is related to an exponential function. And how they are related, we'll talk about it later on when we get to exponential and logs. So log base A of x. If you are a lumberjack, you would like this function. You guys can wait. Log base A of x. A is the base. And if A is 10, we have log base 10 of x. Log base 10, anytime we have base 10, we will just write it as log of x. If A is equal to E, the fancy number that we saw earlier, then f of x is log base E of x. In this case, we get a bit lazy, and instead of putting log base E, we'll call it ln of x. And that is called a natural logarithm. Pretty much everything that we do in math will always go to the natural logarithm. But by all means, the natural log and log are actually related to each other. In the form, I'll do a graph and it makes sense.
Which also is typical when we get to that, your calculators have an option. for-
Yes, that's a good point. So if you pick up your calculator, you will see that there is a button for log and there is a button for ln. Good. So are we clear? And of course, there are other algebraic functions. You have root x plus 1, it's a radical function, and you can have a ratio of radical functions. Or you can have that. So all of these are different types of models, but in algebra, you probably tried a whole bunch of things with every single, type of function. But here, you just have to know the properties. For instance, this is called a natural logarithm. That's a regular logarithm. That E means a special number, 2.71828. And that is the natural base. Those are the things that you have to know. Lastly, there is a model called trigonometric model. I will take it up please. If you like to come and sing, you would like this. Sine function. And then we have cosine function. If you like the beach, you'd like this.
If you bring a partner, it could be a co-tenant.
Wow, he just took it to another level. Thank you, yes. If you bring a partner, that would become co-tenant. We can make multiple combinations of sin x plus cosine x to get a different function. Cosine plus tangent gets a different function. I think after 1.4 or right after 1.3, if you look in the lesson plan, I'm going to go over to Appendix D. Appendix D is trigonometry. So I'm not going to cover everything in trigonometry, but I'm just going to explain the basics and some basic formulas that you need to know in this class. So what does a sine function look like? Well, let's use the calculator. How about that? So let's use the calculator.